If you look on page 129, you'll see a variety of capacitors in the pictures. Notice the electrolytics have a little white line down one side and indicates negative. Okay, you need to pay attention to that when you put it in, or you will blow it up and you're going to have to get another one. They have little creases in the top of the larger ones so that it won't blow the can off. The littler ones don't, and it'll blow the can off. And if you're sitting like this, looking at it, going, what's wrong with it? It'll hit you right about there at about 100 miles an hour, and you'll wish you hadn't been looking down. Okay, and then they'll stink really bad. But the bigger ones have a crease in them, and then they pop the tops off them. When you're in the field, that's one of the things you want to look for. You take the board out and you look at it, and you look at all the tops of the capacitors, and if you see them bulged up or if you see them split open, replace them, because that's probably your problem. I've seen a number of computer boards that somebody had got a return for it, and they're supposed to just throw the board away because it didn't work. And there was like 5 capacitors that just, in fact, they had 6.3 volt capacitors from China for a while. They were no good. They popped. And you just see a line of them, and you pull them all out and you put better capacitors in. Board was good again, and you had a brand new CPU board. Most people say you can't repair CPU boards. You can if you just look at them. Okay, doesn't mean you can repair all of them, but that, for a while, there was CPU boards all over the place. Dell had a whole bunch of them. So, all right, and there are radials. That means the leads come out of the bottom, and they just go right into the board, and you solder them, and they sit upright. There's axials. That just means the leads come out of both ends. They're both electrolytics. You find both of them in the field, and the axials blow the end out on the positive side. They have a little rubber thing in it that blows out or pops out. The radials blow the tops out, and they have creases in them. If you look to the other side, there's ceramic discs. They come in all different sizes. You need to pay attention because varistors look like those ceramic discs also. Varistors are a whole different animal. They're used for surges in a power supply. So you don't want to be thinking it's a capacitor. You look on it, it'll actually have the size and what it is on it. And you can see markings on those there. See that one in the middle says 0.01 M. What does that stand for? Well, that means it's 0.01 microfarads. What do we know about microfarads? That means it's 6 places to the right. Okay, so it's 0.01. It's already 2 places, so that makes it 8 places to the right when you actually write it out. So if you're going to use it in your calculations, you need to make sure you get the right number of zeros when you plug it in. Okay. Variable capacitor right there in 11-6. And paper and plastic capacitors and mylars also now. You won't see the big black one much. Those were in older equipment. They don't use those much. But you'll see the mylars a lot. That little one below, that's plastic and mylar. And you'll see axial mylar capacitors in that configuration also. Notice the band on the black one, that's the positive end. Even though it's not electrolytic, they actually show the positive end with the white band. Can it go in backwards? It won't blow up if it's backwards, but it's preferable to put that in as the positive end. That's what you'll find, okay? And then there's a little hash on, notice the plastic on the right side, there's a little hash. I always put that in the negative side of the board, even though they're non-polar. That's the way they do it, so that's the way I do it in the field. You don't have to, okay? All right, so those are the pictures. By no means are those all of the capacitors you'll run into, but they are the ones that you'll see the most in the field, okay?